All right, this lecture is on types of acceleration. So we're pretty familiar with linear acceleration. An object starts here and it starts moving at a certain velocity, and then the velocity increases, meaning that it's going to, if it goes up, it's going to go up in a parabola shape, and it's constantly going to go faster and faster and faster. That's what the acceleration is, and it's also referring to a force pushing in that way. But when we get to uniform circular motion, object going like this, we become a little bit more unfamiliar with the idea of centripetal acceleration. Now, acceleration is just a change in velocity, but we forget velocity is a vector, meaning it has both magnitude and direction. So changing the direction of the vector from here to here to here to here is also a type of acceleration because we are changing velocity. And now, this type of acceleration is called centripetal acceleration. AC equals v squared over r. That's the formula we use. And this acceleration always points inwards towards the center. Now, when we have a mass of an object traveling around the surface, this becomes mass times acceleration, which becomes a force. But we never label it centripetal force, Fc, equals mvr squared. We never label it Fc. Instead, we label it with whatever corresponding force is actually causing it to stay in orbit, which is why we actually need a force for it to stay in orbit. It doesn't just stay in uniform circular motion itself without a force pulling it back in to make it accelerate centripetally. And so types of forces could be tension. It could be a string that is just moving around. You're pulling it in with the tension of a string. It could be gravity, such as a satellite orbiting in and constantly being pulled by the Earth. It could be normal force, meaning you're accelerating in a tube, going back and forth, and then just pushing you inwards. It could be friction, meaning you're just turning. And it could be all sorts of forces. So we label it F sub c. And basically the acceleration vector is just pointed from the edge inwards, and the magnitude is v squared over r. And then one more type of acceleration is tangential acceleration. This is when the actual speed of the object as it's going in uniform circular motion is actually increasing. So we would not only have acceleration of the magnitude, we would also have acceleration in direction, meaning we have both types of acceleration. But tangential acceleration is only when the rate of speed at any given moment on the how fast it's moving is actually increasing, meaning that it's going around faster and faster and faster and faster as time goes by. And now this is just another type of acceleration similar to linear acceleration, and just the vector is just whatever magnitude in whatever direction it's going in. But these are both types of acceleration. The main thing to remember in centripetal acceleration is that it always points straight inward, and the magnitude of the acceleration is v squared over r. And also that we never label something Fc because we have to actually have a force pulling it inwards, pushing it inwards. All right, so this corresponds to problem number 31, in which we have a uniform circular motion, we have a radius r, and we know that the function of time, w of t, equals bt. And w means the angular velocity, meaning the radians per second is the amount of angle it's traveling per second. And now we're told b is a positive constant, meaning that as time goes by, the angular speed is actually increasing, meaning that as time goes by, it's going to start increasing and going around faster and faster and faster, which also means that there is tangential acceleration in whichever way perpendicular to the position it is, because it's just increasing linearly that way, or tangentially that way, but that's just the direction it's pointing in at that moment. And then, of course, we have centripetal acceleration always pointing inwards towards the center at any given point, and this force that's keeping in is tension here. Actually, we don't know what the force is. We're just told that it is kept in by some force. But essentially, it asks us what the total acceleration vector is at this point up here. And like I described, there is a tangential component going that way and a centripetal part of the acceleration going straight down, meaning that it has parts going to the left and towards the bottom of the page, which is answer choice E.